Swayam Prabha. Digital India. Educated India.
Good morning to everybody. Nice to have you here for the first lecture of the course Geoenvironmental Engineering. I am Professor Manoj Datta. I've been teaching this course for the last 10 years, and over the next 12 weeks we will share common experiences about this course. So let me begin. The word Geoenvironment is made up of two portions, the geo portion and the environment portion. Geo normally refers to dealing with earth, geological materials and things like that. And environment normally refers to dealing with ecosystem. You must protect the environment such that the ecosystem is not affected. So this course is Geoenvironmental Engineering. Now in some of the institutes, in some of the colleges and universities and technical institutes, this course is also known by another name, Environmental Geotechnology. We are doing Geoenvironmental Engineering over the next 12 weeks. This course is also called Environmental Geotechnology. And if I were to look at the keywords associated with this course, it would be geotechnical aspects of waste disposal, design of landfills, slurry ponds, and contaminated sites. In this course, our learning objectives will be to learn about concepts and principles of subsurface contamination. The bulk of the course will focus on planning, design and construction of landfills for municipal solid waste and hazardous waste, as well as design and construction of slurry ponds of coal ash and mine tailings and other slurry deposits. We will look at rehabilitation of old waste dumps, detection and monitoring of subsurface contamination. We will look at what can we do at sites which are already contaminated with waste, what are the control and remedial measures we can take, and what is the geotechnical reuse of waste materials. When you finish this course, you will have many new capabilities. You can be a part of a design team in an environmental consultant's office. So with the new knowledge that you acquire here in this course, you will be able to do design work relating to landfills and slurry ponds. You can be a part of an evaluation team for a regulatory authority. If a regulatory authority is monitoring a landfill, you can be a part of the team which goes and does the monitoring program, looks at the leachate and the landfill gas and other emissions from landfills and slurry ponds. You can be a project team leader for executing a project. That means for designing, constructing and operating a landfill or a slurry pond. You should be, with the knowledge gained in this course, very easily be able to refer to the latest codes, whether it's European practice or American practice or Indian practice. Look at the various codes, guidelines and manuals so that in your designs you can incorporate the best global practices for landfills, slurry ponds and other waste disposal facilities. You will also be equipped to undertake analysis of failures. I mean, if there's a landfill failure or a slurry pond failure, you will be equipped how to analyze the failures and also take remedial action for stabilizing these failures and also take remedial action at contaminated sites to prevent further spread of contamination from these sites. And finally, You will be able to keep abreast of the latest R&D findings. You will be able to go to the journals and the conferences, the latest journals and conferences, and read articles of what is happening in this area and understand these articles. And you will be able to use the R&D findings to arrive at state-of-the-art solutions for your problems. So in the end, sitting through this 42 lectures, you will be able to acquire these new capabilities. So as I said, this course has 42 lectures. This may not be the precise order of the lectures that we will follow, but it gives an idea of what we will cover in the entire course. The correct order is visible on the website of this course. We will spend the first 3 lectures on introduction and soil waste interaction. Including today's lecture, we will have 2 more lectures. So we will see what are the sources of ground contamination, what are the impacts of ground contamination. We will see how, if you put waste on the ground, how does it actually impact the subsurface environment, that is through soil waste interaction. Then a bulk of this course is on landfills. And landfills are solid waste disposal facilities. We generate garbage in the city. Where does it go? I thought in solid waste management you must have learnt about, you send garbage for composting, you send garbage for recycling. But even after you do all that, you must be hearing about waste to energy plants. So even if you take out all the compost from a garbage, all the energy from a garbage, all the recyclables from a garbage, there is still something left. So what happens to that? That is disposed of on ground. So landfills are the facilities in which you dispose of the final rejected material which nobody else can use, and we will be dealing with landfills. And as you can see, we will be dealing with planning and design, and we will be also dealing with construction and operation. So what kind of wastes are disposed of in landfills? Typically, we will deal with municipal solid waste, hazardous waste, and construction and demolition waste. As we go along, we will find that we will be primarily dealing with 3 types of solid wastes: the garbage which comes out from the houses, the hazardous waste which comes out from the industries, and the construction and demolition debris. In a city, everybody is either making another story, or it is demolishing an old home and making bigger homes, or making malls. So all the C&D debris is also being disposed of on the ground. So we will look at design of landfills for these types of waste. Then you will also be dealing with rehabilitation of old dumps. As you can see here, rehabilitation of old dumps is an extension of landfill design. But the problem is that in designing a new landfill, you can prepare the site to receive the waste. Whereas if you have an old dump which is huge like a mountain, then the base of the site is not available to you to prepare it for putting the waste. Then we have to do everything on the top. And then how do we tackle an old waste dump which is very large? If it's a very small dump, you can say, all right, I will excavate it, I will do something and prepare the ground for receiving the waste. But if it's a huge dump, has any of you seen a garbage dump of your city? So where do you belong? Debanjana? Which city do you belong to? Okay. Is there a waste dump in Guwahati? Or you don't know about it? Okay. Anybody who has seen a waste dump? A garbage dump? Who? So which garbage dump have you seen, Avinash?
It's there in Guwahati city.
She says it's not there in Guwahati city, and now you say no, it's there in Guwahati city. Okay. So do you remember its size, approximate size?
It's around, sir, there are
How many? Is it 100 meters wide to 200 meters wide?
around 200, 300 meters.
So it's about 200 meters into 200 meters. Is that a rough idea? Yes, Mohit, you said you have seen a dump. Where have you seen one?
So recently in Hyderabad,
You have seen a waste dump in Hyderabad. So how wide is it approximately?
sir, around 250 meters wide.
Well, I think I have seen the Hyderabad main waste dump. I think it's about 1 kilometer wide. So if you look at the base of the dump, when I am talking of width, I'm not talking of how wide it is at the top. I'm talking of how wide it is at the bottom. So I think it's a much bigger dump. So anyways, what I'm trying to say, and what is the height of the Hyderabad waste dump?
Sir, around 70 meters, yet not sure because it is unstable, uneven.
So waste dumps can be 20 meters, 10 meters high, 30 meters high, and that kind of height. So if you have a huge dump of that height, it's very difficult to move the waste. So under rehabilitation of dumps, we will be doing, what do you do with these old dumps which have accumulated at a site? Then another topic that we will be covering is slurry ponds. What are slurry ponds? If you see thermal power stations, coal comes to thermal power stations, you burn it and ash is generated. So typically for every 100 units of coal which comes, about 35% of it is ash. So these thermal power stations are producing huge quantities of ash, and the coal is coming on from, where does the coal come from at a thermal power station? From a coal mine. And we have 3 thermal power stations in Delhi, but the coal is coming from Bihar. So the ash does not go back. The ash after burning remains at the site where the electricity has been generated. So this ash has to be then placed in a waste dump unless it is reutilized. So to transport ash from the boilers where it is generated to the waste dump, often they will mix the ash with water and transport it in the form of a slurry. So two major types of wastes go to ponds, slurry ponds. One is coal ash and the other is mine tailings. Suppose I am extracting, let us say, zinc. So what do? I dig up the earth, I mine it, and I bring out an ore which is rich in zinc. To take out the zinc from the ore, I will crush it, crush and crush and crush. After you have crushed, by some technique, whether it is a gravimetric technique or otherwise, the zinc will be separated from the crushed rock. The crushed rock is called tailings, and this is also transported from the mine to a waste disposal site in the form of a slurry. So we will be looking in this course on design of slurry ponds, and that is very different from a garbage dump, because the garbage dump is not transported in the form of a slurry. So far what have we discussed? We have discussed, if I have ground, I can put waste on it like municipal solid waste. So that becomes a situation where you have to design a landfill. If I have the waste coming in the form of a slurry, how do you think I store slurry on ground? Slurry will come to you in the form of a pipe, let's say an 8-inch diameter pipe. So, should I bring the pipe and start disposing the slurry here? What should I do? You should excavate it. Well, that's a lot of cost. So you have to create a kind of a pond, whether by excavation or whether by putting embankments. So maybe what I'll do is I'll pick up some soil from inside and I'll make an embankment. It's like making an artificial lake because the slurry is full of water. And then what happens? I send the slurry spreads in the form of water, and what happens? The particles which have been mixed with the water settle down. So my tailings or my ash will settle down here, and I'll have water here, and finally I can recirculate the water. So how do you design a facility like this? How do you design a facility like this? How big is it? Typically, a slurry pond may be 1 kilometer by 1 kilometer in base area. And to what height can it go? Well, there are ponds which are going as high as 20 to 30 meters or even more. So that is part of this. The next topic which we looked at is the topic of contaminated sites. What are we going to cover in contaminated sites? So far we've been talking of solid waste, we've been talking of slurry waste, but a contaminated site is on which any waste has been disposed. It can be liquid, it can be slurry, it can be solid, it can be in a drum, it can be sludge, it can come in a truck. So if you have a site on which something has been disposed of for a long period of time or for a short period of time. Let me say there is an industrial area from which chromium sludge is coming out. The chromium sludge is like a thick slurry, and they are using some abandoned area for disposing of the sludge or the slurry. Then gradually with time, something will happen to the subsurface environment. So contaminated site may be because an underground tank is leaking. Which is the most often liquid which is stored in underground tanks? Petrol. We have, how many petrol stations do you think Delhi has? 5, 10, 100, 1,000? Well, it will be between 100 to 1,000. So each petrol station, does it store the petrol above the ground or under the ground? Why not above the ground? Pardon? There's more danger that if there's an explosion or if there's an external event, it can spark something. In any case, so the world over, all the gasoline and the petrol is stored underground. If it leaks, it goes into the ground. So that becomes a contaminated site. So a contaminated site is one in which some contaminant has been released in any form, solid, liquid, slurry, even volatile organic compounds. So such sites have also to be first identified. They occur a lot in industrial areas. You know, you are an owner, you started an industry. It didn't work out. After 4 years, you want to sell. Now, law requires that you have to, if you make this deal from one owner to another, the land which you transfer should not be contaminated. And this means you have to detect whether there is any contamination. And if it is contaminated, you have to monitor it and you have to remediate it. So that is a total different topic in comparison to these solid waste disposal facilities. Finally, we will look at geotechnical reuse of waste. You can see this. in this, what are we targeting? What we are trying to say is, when we create these mounds of waste, we are using good fertile land, they become an eyesore, they are going to remain there for the rest of your life, it's a solid waste. So can we reuse it? Which industry has a large volume reuse of materials, or which sector has large volume reuse of materials or use of materials, let us say? Power sector produces the waste. What will it do with the ash? Power sector is using coal, it is giving you electricity, but ash is coming out. What will you do with the ash? Yeah. So the only thing that is happening a lot in this world is cities are rising vertically. You can only rise vertically if you are getting some material to make these cities. So what is the traditional material with which we construct by which these cities go up vertically? Maybe concrete, maybe steel, maybe wood, but many natural materials are used. In the production of concrete, what is the material that is the most significant portion? Cement? So cement is a small portion of concrete, but sand, fine aggregate, coarse aggregate, water. So basically, again, these are natural materials which are being utilized. So for cities to go up, we have to dig materials. To make the bricks, we have to dig the soil and burn it in the kilns to make the bricks. So as cities go vertical, we use large volumes of soil and aggregate. So one of the thoughts is, can we reuse waste in this industry? So geotechnical reuse is not for construction of buildings. Geotechnical reuse is for the purpose of earthworks. Please understand, where all do you use soil for earthworks in abundance? 3 locations. If you have a low-lying area, you want to raise the ground level, then you need earth. If you are not going to use it from very far, you will start digging up from nearby and bringing that earth. That doesn't serve any purpose, because where you are digging, you are making that low. So for filling low-lying areas, then making embankments. So in Delhi, for example, सबसे ज़्यादा earthwork, where is the maximum amount of earthwork taking place? Can anybody guess where a lot of earthwork is taking place in Delhi? Every time you construct a flyover, there is an approach embankment. You know how high is the flyover? 40 meters is too high, 70 meters is Qutub Minar. So it's more like 10 meters. So you have a road which is at ground level, and you have a flyover which is at 10 meters high, and you have to make an approach embankment. So to make the approach embankment, you need soil. So in Delhi, a lot of earth is used for making the approach embankments for these flyovers. So currently, what do? We go outside Delhi, we look for barren land, and there is no ownership or nobody is interested in it. We buy the rights and do earthwork. But all the barren land is gone, or it has become low-lying because you have been excavating from there. Then you go to the farmer and say, will you sell me your fertile land so that I can make a approach embankment for a flyover in Delhi? The farmer says, no, this is my livelihood. Then you may go to a place where there is waste lying, which has soil-like properties, which is not hazardous, and then you have a win-win situation. A thermal power plant may have a waste which is of no use to them. You may be able to get a waste which is soil-like, provided you then check its geotechnical properties, and then you can use it. So in geotechnical reuse, we will look at such kind of applications. Where are we going to substitute soil with such material? And final topic is regulations and case studies. Regulations and case studies will not be covered as separate topics in this course, but will be referred to time and again when we discuss the other topics. So, everything relating to contamination and pollution is regulated by the Central Pollution Control Board. So, from time to time the Ministry of Environment and Forests and Central Pollution Control will bring out these regulations which you have to follow, and they also bring out guidelines, which are guidelines but are not the law, but they give you a framework that they expect this minimum guidelines to be followed. So, we will look at regulations and guidelines published by, mostly we will look at the Indian regulations, but also maybe you will go back and look at some international or global regulations. So, which is a big environmental agency whose regulations are very popular? US EPA, the US Environmental Protection Agency. Then we also have European regulations. So, we will also try and see what is happening in some of the other countries. We will also look at some case studies about these materials. So, case studies will relate to landfills, some slurry ponds in which IIT Delhi has been involved. So, we will share those experiences with you. And if time permits, we will look at a little bit on geothermal energy and other associated subjects. So, any questions at this stage which come to your mind? No questions. Okay, then let us continue. So, if you go to Google and punch in environmental geotechnology or geoenvironmental engineering or landfills, all the keywords that I have given you, you will come up with 50, 60, 100 books. So, these are only some of the books that are recommended, but the first book, that is David Daniels' book, this is the Bible from where environmental geotechnique started. And this is what we will follow for bulk of the course. This is what we will follow for bulk of the course. The book on waste disposal in engineered landfills, this has been authored by me and it came up in 1998. It's more suitable for Indian conditions and design of landfills, not for everything else. And Quinn and Koerner's book is more recent for landfill design, the details of landfill planning and design. As far as slurry ponds are concerned, there is only one book. You will come across a lot of conference proceedings on ash, on tailings, dams, tailings impoundments, but to be written in the form of a textbook, this is an old book by Wick. It discusses the subject very well, and this is what we will use for the purpose of our current class. And Gulati and Datta is an undergraduate come postgraduate level book which has 6 chapters on geoenvironmental engineering, but they are elementary chapters. They can be used as your starting points for this course. So, these are the textbooks that we will follow. You are welcome to read up many more books. There is a book on environmental geotechnology by Sarsby. There are books on landfills by Bagchi and by Reddy and Sharma, and there are many other books. So, you are welcome to get the flavor from those books as well. All of you are expected to learn about waste characterization. So, suppose I come and give you a material. Let me assume I have got some little bit of powder in my hand. I don't even know whether it is hazardous. So, let me say, all right, come take this, please take, come. It may be hazardous. Take, okay, now go back. So the question is, I have handed over some powder to you. Now what is it? Waste characterization deals with answering the question, what is in your hand?
So it's a waste powder.
It may be talcum powder. It's
What are its properties?
so the only thing you can tell when I give it to you in your hand is what is its color and whether it is fine or coarse. So everything else you have to do for characterizing it. So waste characterization means how do you discover a material which is powdery in nature? Is it soil? Is it ash? Is it talcum powder? Is it hazardous? Is it non-hazardous? Is it inert? Has it got a biological component? Is it biodegradable? Is it food waste? Maybe you can smell it also and say, sir, this is not smelling very good. Quite clearly it has an organic content. So therefore it may not be the best. So you will have to learn about how to characterize waste. We'll give you the introduction here, but you'll have to self-learn about it. So let me again try to put this in a nutshell. Geoenvironmental engineering or environmental geotechniques deals with contamination at the ground surface and beneath the ground surface, right? It deals with contamination at the ground surface and beneath the ground surface. The contamination can occur if you have solid waste. The contamination can occur if you are storing some waste liquid in a pond. It can occur, you have buried pipeline. It can occur, you have buried storage drum. So there can be different sources, and we will do that in the next lecture. So the first part of this course is all about design of a facility where we are going to put the waste. So purely philosophically, how would you go about this problem? If let us say, just assume that this is all on sand, right? This is municipal solid waste. Will municipal solid waste contaminate the sand? Will municipal solid waste contaminate the sand? That's the first question. Yes or no? Why? It will walk into the sand. It will have some leachate. Where will the leachate come from? I don't know what is leachate, but okay, you use the term. You mean to say it will have some liquid. With the liquid, it will have some contaminant. So will the waste physically go and intrude into the sand? No. So it will need a medium to transmit the contaminant from the waste to the soil. So perhaps what he is saying is, if you have waste and if rain falls on the waste, then it might go and contaminate the soil, right? Because then it will percolate through the waste and contaminate the soil. But what about this? This is liquid waste. And suppose it has got some, where did we go recently? To Pune, and there was some wastewater which was being stored in a pond, and it had some dark color, and then people were reporting, no, they are seeing dark water in their wells. So this can percolate unless you design. So I'm trying to now get to this. So when I know that this can contaminate the ground and this can contaminate the ground, how will I design? What will be my design philosophy?
We have to restrict the flow of the contaminant.
We have to restrict the movement of the contaminant from the waste to the surrounding environment. So the philosophy is that we have to do something in terms of engineering which prevents the contaminant to move out from the area in which the waste is stored, right? So the first part of this course on landfills deals with this philosophy. It deals with this philosophy. The second part of the course on contaminated soil sites deals with the philosophy that if contaminant has already gone into the ground or it is already there on the ground, and normally beneath the soil you will have a groundwater table. So it is possible that the soil will get contaminated and the groundwater inside the soil will also get contaminated. So the second part of the course wants to know how much of this has got contaminated. You have to detect it, you have to quantify it, and then if it has got contaminated, what should we do? How do we remediate it? How do we reverse it? Or if not reverse it, prevent it from spreading more, because reversing it may be very expensive. So again, as an engineer, what would you do to this? As an engineer, what would you do to this? You would like to put you put these beautiful containment structure here, you would like to do something like this so that it doesn't travel off the site. So the entire engineering, can we do this? Can we put something like this under the ground? Is it costly? Is it doable? And what is this? What is this material? Is it concrete? Is it steel? Is it soil? Is it bitumen? Is it polymer? Is it geomembrane? What is it? Is it a combination of that? That is what this course is all about. That can we design facilities which will not impact or harm the environment, and if some subsurface contamination has already taken place, then can we do something about it? Can you quantify it, and can we do something about it? So that's the part of what we are doing here. So we'll have some evaluation. As usual, there are 100 marks up for grabs. You can always get 100 out of 100. And so since there is significant self-learning components, the assignments will have 25 marks. So then let's quickly do 3 or 4 more slides, and let's first look at the definition of geoenvironmental engineering. As I said in the beginning, it's a confluence of geotechnical engineering and environmental engineering, dealing with solutions for protection of the subsurface environment as well as public health and promotion of sustainable development. So basically, we are going to do the engineering of protection of the ground or the subsurface environment, and of course promotion of sustainable development by protection of public health. So it mainly deals with prevention of ground pollution and subsurface pollution. That is, in the new facilities which you are going to design, you have to be able to underwrite, just like you make a structure. Are you underwriting as a civil engineer that this building that we are in, what is the life of this building? I think I'm in a 5-storied building or something like that. So what is the design life of this building? 50 years? Okay. Are you certifying that it will last for 50 years? Yes or no? If you don't, I won't hire you to design my building. You have to design a building and construct it and be ready to stand in the court of law and say that this building will, and if it falls, I am responsible for it. Whether there's a hurricane, an earthquake, a tsunami, a tornado, whatever, flood, what else? Extreme events. Despite any of that, you have to be able to design it and say it will last for 50 to 100 years. So, if you are going to design a facility to prevent subsurface contamination, you've got to certify that it will perform for the design life of what we people deal with. 50 to 100 years is what we deal with, and you have to be totally responsible for it if it leaks. So that's what we will do in this course, that you will learn how to design these facilities so that they don't leak for the next 50 to 100 years, right? And then of course also the solutions for the detection and control of the pollution. And what we, please note two words that those are being used, as well as remediation of degraded land. Once a land becomes polluted, you cannot sell it from one owner to another till you bring it back to same level as original condition. So there are very stringent norms in the developed countries for degraded land or land which has undergone contamination. In India, these are just being formulated. And there are many sites in industrial areas where the original owners have closed the industry and the ground is polluted and a new owner will not buy it. You know, we have these industrial development areas, and these industrial development areas, a new owner will only buy it if the land is clean. He doesn't have to have the liability of trying to clean up. It's a very expensive exercise. Cleaning of contaminated sites is a very, very expensive exercise. So this we have already discussed. If you have solid waste and if there is rain, it will contaminate the soil and it will contaminate the groundwater. If you have a pond, if the pond has got drinking water, if it's a lake, doesn't bother me. It in fact acts like a recharge for the groundwater. But if it has got wastewater and you have just put a notional liner, I'll do brick lining. So brick lining is as impervious as the number of joints it has, and every brick has a joint. So it's virtually going to contaminate the groundwater. And then this contamination will flow, and normally the groundwater is flowing to a nearby river, normally. See, if you look back in time, civilization as it developed, cities only came up near rivers, on the banks of rivers, because that's where the water was. And that's where the groundwater was close to the ground surface. So you could put in a hand pump to take out the water. Now that we are able to transfer the water by pipes to very large distances, we live in areas which don't have a permanent source of water. But mostly cities will have either a river or a lake nearby. So let's look at a city which doesn't have a river or lake nearby. Let's not go to Rajasthan. So I've lived in what? I've lived in Chandigarh, which has a lake nearby, and the Ghaggar river. I've lived in Delhi, which has the river Yamuna nearby. Have I lived anywhere else? I've lived in a place called Nangal in Punjab, which had a huge, the river Satluj passes next to it. So does your city have a river nearby? Madam? Guwahati has a river, the Brahmaputra. What about, where do you come from, Feroz? Where is that? So you must be having some rivers flowing by, because in a hilly area you will always have some watershed. Anybody lives in a city which doesn't have a water source right next to it within 20 kilometers? So most of us do realize that there is a water source, therefore there will be a water table, unless we have depleted it, and therefore this is a problem. So I'd like to end by talking about air pollution, water pollution and ground pollution, because we are only dealing with ground pollution. Air pollution is visible, smog is visible, or it is smellable. Even if it is, it will be the rare odorless contaminant which will be there, but there can be gases which are odorless and colorless. The great tragedy we had, which great gas tragedy we had? Yeah. So, but in any case, the thing with air pollution is that pollution doesn't stay at that point. If you have a chimney and there's some bad stuff coming out of it, Let's say this is some industry, and then something is coming out of it. Not too good. Dark black clouds and stuff like that. But it's not going to stay there. It disperses with the wind. And when they close it for the night, they come next morning, it's gone. And some liquid will also come out, liquid waste. So if liquid waste is coming out of my industry, I don't want to treat it, what will I do? I'll take a pipe outside my boundary wall and if there's nobody living next to me, I'll say, अच्छा भाई वहीं dispose कर देते हैं. So if I dispose the waste on my adjacent plot, what happens to that water? Wastewater, liquid. Pardon? I don't think so, because what happens to all rainwater which falls on the ground? जब बारिश होती है तो पानी कहाँ जाता है ये तो? Yeah. So the tendency is to first to run off in the natural slope direction. Yes, it will percolate maybe a little bit, a few centimeters or a few inches, but the tendency of water is to run to a low-lying area. The low-lying area is normally a drain which runs to a river. That's the, I mean, IIT में low-lying areas हैं, दो नाले हैं ना. So, yeah, you put, no, it rains, what happens? The water doesn't stay there. And if you, after the rain, if you dig beneath the ground, if you think that you will find that water 1 feet below the ground, it's not going to be there. The water drains off and goes to these low-lying areas, and these drains then eventually connect to the larger drain which takes it to the river Yamuna. So what happens is, when you have liquid pollutant coming out of a boundary, it will eventually find its way to a waterway, eventually, if a lot of it is coming out. If not a lot of it is coming out, it will partly evaporate, partly go into the ground. But again, that does not stay there. If there's a natural depression, yes, a bad smelling pond will be formed. And then the factory will stop throwing the thing there because they'll be getting their own pollutant back through the poor smell and stuff like this. But what happens to solid waste? You put solid waste and what happens? It just remains there. It doesn't vanish. Will it vanish in a year? Or what about 10 years? Some biodegradable part of the garbage may degrade. It will become, so I put a heap, it will become smaller. Then what will happen? Some of it will erode with wind and water, but that mound will stay there. And eventually it will become flatter and flatter because the rain will keep on making spread. It will spread in that area, but it won't go into the Indian Ocean from here. So solid waste, ground pollution, that means you put water also on the soil, the topsoil becomes wastewater on the soil, the topsoil becomes polluted, then it just doesn't go anywhere, it just stays there. Or it goes into the ground, pollutes the ground and travels with the groundwater. But the velocity of the groundwater is much slower than the velocity of the surface water. So don't expect groundwater to travel several kilometers in a day. That's the biggest problem about ground pollution. So when I put solid waste here, I have a real problem. It just doesn't, and I keep on producing more waste, and the mound keeps on becoming bigger and bigger and bigger. If you have gaseous waste, you can treat it. First, the thermal power plants used to give a lot of smoke. Then we put electrostatic precipitators. Now you can hardly see the plume. But what is being captured in the electrostatic precipitator, where does that go? So when you treat gas, when you scrub it, when you treat it, either a sludge will be formed or a solid will be formed. Electrostatic precipitators capture all the fine ash. It goes to the ground. If you have liquid waste, you send, please make an effluent treatment plant. What does the effluent treatment plant do? It has to capture the contaminant somewhere and then allow the clear or the good quality water to move out. So what happens? There's a pipe, there's an effluent treatment plant, from the other side comes out clean water. What is being generated by the effluent treatment plant? Sludge. And what do you do with the sludge? Land application. So the contaminant is there, still there in the sludge. So solid waste, if you see, gaseous waste treated by air pollution control devices produces solid waste. Example, electrostatic precipitators produce ash. Liquid waste, example, effluent treatment plants produce sludge. All of this is disposed on land. So the solid waste, we either try to recycle it, or we try to process it, or we try to reuse it after processing. But finally, it is disposed on land, and it tends to remain there for a long time. So again, philosophically, what would you do with solid waste? You could recycle it, you have recycled. Suppose we'll say we'll take out the plastics, we'll recycle it. Fine. We'll take out the compost. Fine. Then next, we will take out the metals and the glass and everything which is reusable. Fine. Still something remains. Then next, then dump it. But really, we would like to convert that material into an inert glassy matrix so that nothing comes out from it. So therein lies the biggest challenge, that can we convert a solid waste into a glassy matrix in which the contaminant remains embedded and does not get released to the environment. So currently, we don't have a solution for that. The people keep on talking of a process called vitrification, or some kind of an in situ glassification, where I'll get 2 electrodes and apply thousands of volts of electricity and zap it and it will become glass. So that probably is the future, but currently all the waste which is not used remains on the ground, right? So geoenvironmental engineering is an interdisciplinary area. Nobody wants to deal with solid waste. It's a 3-phase matrix: solids, liquids and gases. Only geotech people have been handling, we are handling 3-phase or 2-phase? Well, we deal mostly with saturated soil because that is the weakest condition, so that's a 2-phase media. And if we deal with dry soil, that's also a 2-phase media. But if you deal with partially saturated soil or unsaturated soil, then we are used to dealing with 3-phase. So we need the inputs in this area, the geotech people, the environmental people, all the contaminants we are not very familiar with. Everything relating to flow, hydrogeologists and the geology. If you are dealing with agriculture, you need to know about the balances. So you need geochemists, soil scientists and agricultural engineers. We need mining engineers because we dig a lot of things out of the bowels of the earth from deep below. For example, at Hatti gold mines, the ore will come from maybe 1 to 2 kilometers below, then it will be crushed, and then it will come out as tailings. And in that tailing there will be some chemicals, because your aim is to take out the gold. And whether you use a froth flotation process or a chemical separation process, you will add something to that. And then what is remaining is the waste, and that has to be exposed to mining engineers. And finally, chemical and biotech engineers. If we are dealing with municipal solid waste, municipal solid waste is a very heterogeneous mix, so we need to have these people. So that is what the complete geoenvironmental matrix is. We are only on one end of it, but we are the only guys who can drill holes, who can take samples in 3-phase media, and therefore we are better placed than others to be able to address this issue. So I just went to the website and I looked at, I punched in groundwater contamination, and I found, I'm just going to share 2 images with you, and these images are attributed to the UK Groundwater Forum. So if I have a landfill or a pond, eventually it's going to come below the contaminant which is there, and you will have contours of concentration, and you can get to know how the contaminant travels with time. So this is in our domain. We can look at this. But as I have told you, the distance of travel may typically not be several kilometers, but it may be a few hundred meters or maybe a few thousand meters. And if you look at a city, if you look at a city as a whole or as a place, you can have subsurface contamination from landfills, from petrol stations, from industrial areas, from septic tanks. The manure and the pesticides which you are putting will go to the river or to the drain, and that drain. And suppose you have a tube well which is taking out the water for water supply purposes. Then you are the recipient. Whether the tube well is extracting this water for water supply or whether it is extracting it for irrigation purposes, it draws all those, because you have a drawdown curve, it draws all those contaminants towards itself. And that is where it impacts public health. And that's why it is so important to address this. So just to summarize, we've just introduced ourselves to the topic of geoenvironmental engineering and what we are going to cover in the next 42 lectures. And I think you now have a fair idea that we are going to look at design of new facilities. We are going to see what we are going to do to old dumps, and we are going to see how we tackle contaminated sites. Over and above that, we are going to treat slurry ponds separately from municipal solid waste, hazardous waste, and construction and demolition waste dumps. So next time we'll look at sources of contamination and their impacts. Thank you.